Okay, then now we are going to learn about the methods of preparation of haloalkanes. Okay, methods of preparation of haloalkanes. Can you hear me?
Yes, ma'am.
Okay, just wait. Methods of preparation of haloalkanes. So there are different methods for the preparation of this haloalkanes from different compounds. Just 1 minute. Okay, so the first method of preparation of haloalkenes, it's from alcohols. Okay, from alcohols. And from this alcohols itself, there are different methods. That's in your textbook, page number 294. Okay, you can see there many chemical reactions. All these are different methods to prepare this haloalkane from alcohols. Okay, among these different methods, the thionyl chloride. Okay, thionyl chloride. It's a reagent, and its chemical formula it is SOCl2. Thionyl chloride, it is SOCl2. This method is very much preferred. Okay, this method is preferred because along with this haloalkanes, other products are obtained, that is sulfur dioxide and hydrochloric acid. Okay, sulfur dioxide and hydrochloric acid, and both. Is my voice breaking? Yes or no?
No, ma'am.
No, ma'am.
Achu?
Feel like it's breaking.
Okay. Okay, so we are preferring this thionyl chloride method because the side products obtained along with haloalkenes, they are sulfur dioxide and HCl, hydrochloric acid. Both these are S-capable gases. Okay, they are volatile in nature. That means easily converted to vapors. So it is very easy to separate this haloalkene from this compound. So we can write there, the thionyl chloride, it is preferred because in this reaction alkyl halide is formed. That is also known as haloalkane. Okay, alkyl halide is formed along with gases SO2 and HCl, sulfur dioxide and hydrochloric acid. Two gases are escapable. Hence the reaction gives pure alkyl halides. That's the reason. Pure alkyl halides. Then the chemical reaction here, that is ROH. That's to represent alcohol. Okay, OH group, that's for alcohol, it's a functional group. Then R for hydrocarbon. It's any chain, CH3, CH2. So in order to represent this alcohol, we are using ROH. Okay, ROH plus SOCl2, that is thionyl chloride. SOCl2, that is thionyl chloride. So the products obtained are Cl plus HCl plus SO2. So this is the one method to prepare this haloalkene from alcohol. Okay, using thionyl chloride as a reagent. It is preferred because in this reaction alkyl halide is formed along with gases sulfur dioxide and HCl. Two gases are escapable, hence reaction gives pure alkyl halides. Okay. This is clear? Yes. Finished? Okay, then you can complete it. Finished, right? Then the second method, here the starting material is alcohol itself, okay, but another method from alcohols to prepare this haloalkane. So the second method, first you can write the chemical reaction, then you can able to write it in the form of a sentence. ROH plus HCl gives RCl plus H2O, and here zinc chloride. This is the second one. It's also from alcohol. Alcohol reacts with hydrochloric acid or HCl in the presence of a catalyst zinc chloride to form alkyl halide and water. Right here, reaction of primary alcohol, reaction of primary alcohol, not only primary and secondary, sorry, primary and secondary alcohol. Primary and secondary alcohol with HCl in the presence of catalyst zinc chloride, alkyl halide is obtained. Alkyl halide is obtained. Then in the case of tertiary alcohols, children, do you know what's the difference between primary, secondary and tertiary? Yes, right? If it is attached to a carbon atom that has only one substituent, it is primary. Then two substituent, it is secondary. Then three, it is tertiary. That's it. Okay? Yes. So in the case of this tertiary alcohol, it can be converted to alkyl halide by simply shaking with HCl at room temperature. Okay, by simply shaking with concentrated HCl at room temperature. Alkyl halide is obtained. In the case of primary and secondary alcohol, it should react with HCl. In the presence of catalyst zinc chloride, alkyl halide is obtained. And in the case of tertiary alcohol, by simply shaking with concentrated HCl at room temperature, the alkyl halide is obtained. This is clear? Yes. So there are different chemical reactions here. In the case of method of preparation also, It's from alcohols, hydrocarbons, alkenes, halogen exchange reaction. So many reactions are there. Then in each heading there are different types of methods. So you have to write this equation and learn it. Okay, if you can able to write the equation, then you can able to write the equation in the form of a sentence, right? Yes. So you should practice this chemical equation by writing this. Okay, when you just read this chemical equation and try to learn, you will not able to remember it for a long time. So you should practice it by writing itself. So that's about this method using concentrated HCl. Shall I move to next one? Okay. Then the next one, phosphorus tribromide. Okay, phosphorus tribromide or phosphorus tribromide or triiodide. Okay, both are halogens, right? Triiodide. Phosphorus tribromide and triiodide are usually generated by the reaction of red phosphorus with bromine and iodine respectively. If you want to prepare phosphorus tribromide, then red phosphorus with the bromine. If it is phosphorus triiodide, then phosphorus with iodine. That's it. And the chemical reaction here, ROH. Here the starting material is always alcohol. Okay, alcohol, then red phosphorus. Red phosphorus, it's a type of allotropic form of phosphorus. Okay, there is white phosphorus there, then black, red. Red phosphorus in presence of halides, we will get the respective tribromide or triiodide. X2, that is equal to Cl2 or Br2. This is another chemical reaction or another method for the preparation of this alkyl halide. Okay, sorry, it's iodine, I2. Yeah, Chu?
Can change that eraser.
Once again?
No, can you change the eraser from there?
Where is it?
Cursor, ma'am, cursor.
No cursor here.
Now it's gone, ma'am.
Okay. Then another method, constant boiling with HBr. Okay, constant boiling with HBr. That is used for preparing alkyl bromide. Preparing alkyl bromide. Okay, these are just 4 chemical reactions from this alcohols. There are so many reactions here in this section from alcohols. So you should read the textbook. Okay, the same portion from alcohols. Here the starting material is same and the product obtained is same. Okay, only change in the reagent and the side products. Sometimes catalyst is also used. So these are certain techniques or certain methods for the preparation of haloalkane or alkyl halide from alcohols. Okay, I am discussed only 4 reactions. More than 4 reactions in your textbook. You have to read this portion very well. Okay. Then we are moving to the next one, that is from alkanes by free radical halogenation. So the second one from hydrocarbons. Okay. First section is from alcohols, then the second section is from hydrocarbons. So the second one is from hydrocarbons. From hydrocarbons. And both this alkanes, alkenes, alkynes, they all belongs to this category. So first one from alkanes. From alkanes by free radical hydrogenation. By free radical, halogenation. What do you mean by halogenation? Halogenation. Can you tell me? Addition of halogen, right? So here from alkanes by free radical halogenation. When you heard this term, free radical, you should remember the presence of light is there. Okay, free radical halogenation, or you heard the term free radical, that means it's in the presence of light itself. Okay, so from alkanes by free radical halogenation. So we can write the chemical equation first. CH3, CH2, CH2, CH3. Okay, then free radical halogenation, that means addition of halogen. Here chlorine is added, Cl2, in the presence of UV light. UV light or heat. Then 2 products are obtained here. Okay, 2 products are obtained, and here these 2 products are considered as, one is major and the other one is minor. That produced in large amount, it is considered as major, and that produced in small amount, it is minor. So it is CH3, CH2, 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 Cl. We just removed 1 hydrogen from this position and chlorine is added. Okay, look here, from the last one, from CH3, 1 hydrogen is removed and 1 chlorine is added. That's a one product. Then another one, CH3, CH2, CH, Cl, CH3. This is the another product. So here this chlorine is in the second position, right? Second position. And this free radical halogenation, that means free radical chlorination or bromination, it gives a complex mixture of isomeric mono and polyhaloalkanes. Here you can see that different types of haloalkanes are formed, right? So it is very difficult to separate them as pure compounds. Look at this example itself. There are 2 products are formed here. It is very difficult to separate these 2 compounds into its own forms. Okay. So you can also write this point, free radical chlorination or bromination of alkenes. Bromination of alkanes gives complex mixtures complex mixture of isomeric mono and polyhaloalkenes. Sometimes one halogen is substituted, otherwise more than one. Which is difficult to separate as pure compounds. Okay, that's the difficulty here. And I told you one product is major and other one is minor. The yield of the compound that is in more quantity or larger quantity, it is considered as major, and the other one is minor. Yes.
Is it gives complex mixture of isomeric mono?
Yeah, isomeric mono and polyhaloalkanes. Have you completed? So first method, that's from alcohols. There are different methods from alcohols to prepare this haloalkenes. The most preferred one, that's from thionyl chloride, because the side products obtained are sulfur dioxide and hydrochloric acid. They are escapable in nature. Then we learned different methods there, HCl in the presence of zinc chloride, then red phosphorus with chlorine, bromine, iodine, etc. Then with continuous heating, constant boiling, different methods. Then the second one, that's from hydrocarbons. In the hydrocarbons itself, from alkenes by free radical halogenation. So when you heard the term free radical halogenation, presence of light or heat is there. Okay, then the hydrogen in the terminal carbon atom or the hydrogen in the terminal carbon atom or any carbon atom that can be replaced by this chlorine. Okay, that means an isomeric form of products is obtained, and it is very difficult to separate these compounds in the pure form, and one is obtained as major product and other one is minor product depending upon their yield. That's it. Shall I move to next one? Yes. Next one, from alkenes. It comes under the category of from hydrocarbons, from alkenes. Okay, here there are two methods. First one, addition of hydrogen halides. Addition of hydrogen halides. Can you tell me one example for hydrogen halide? Hydrogen halide. Vidur, tell me one example of hydrogen halide.
HCl.
Yeah, HCl is an example for hydrogen halide. So this alkene, it is converted to corresponding alkyl halide by the reaction with this hydrogen halide. Includes hydrogen chloride, hydrogen bromide, hydrogen iodide. These all are hydrogen halides. So this is an alkene, and we just add HX. X stands for halogens. It may be chlorine, bromine or iodine. That's it. Then here this double bond, it breaks. Okay, this double bond, it breaks and hydrogen is added to one carbon, then halogen is added to another carbon. That's it. You have learned different types of reactions in class 10, right? Combination, then addition. So in the case of addition reaction, that generally take place in the case of double bonds. When you add certain compound to double bonds, that double bond will break and these two elements, they are substituted on both carbon atoms. Okay. Yes. Then here one more thing, both the sides of this double bond, they are symmetrical in nature, right? Look at the both sides of this double bond, they are symmetrical in nature. That means this carbon, it is replaced by, it is substituted by the same groups. Okay. If this double bonded carbon, it is unsymmetrical in nature, that means the number of groups or different groups are there in the both sides of this double bond, we will follow one rule. Okay, we will follow one rule and it is known as Marconi-Coff's rule. This is clear, children? This one is symmetrical in nature, that means both sides of this double bond, they are equal, right? That means two R groups are here in the left side, in the right side also two R groups are there. If they are not symmetrical in nature, we should follow Marconi-Coff's rule for the addition of this hydrogen halide. Okay, and this rule will tell you which among these two elements, which one will goes to which side. Is this clear? So we can do one example of this unsymmetrical alkene. HI. This is an example for unsymmetrical alkene and there are two choices there. This hydrogen can be added to left side or right side, then iodine also added to left side or right side. So according to this Marconi-Coff's rule, there are two choices there, but the rule that shown by this Marconi-Coff's rule, that should be considered as the major product. So there will be two products there, one is major and minor, other one is minor. This major product will be estimated according to Marconi-Coff's rule. So can you tell me which are the products obtained here? You can tell me the two choices. Diya, can you tell me the product? Just break this double bond, then add hydrogen and iodine to two sides. Yes. CH3CH. Yeah, CH3CHH, then I. This is one product. What about the next one? We can write this CHH as CH2, right? CH2, okay. Then what about the next product? Diya? CH3CHI, very good. Then CH3, right? Yes, CH3. So these are the two products. Among these two products, this one is considered as major product and this one is minor product. Okay, this one is considered as the major product and this one is the minor product. Then this Marconi-Coff's rule, it states that when you add one any group to this double bonded carbon, that means to alkene, the negative part of this reagent, that will be added to the carbon with lesser number of hydrogen atoms. Clear? The negative part, which is the negative part in hydrogen and iodide? Iodide, right? This one is negative and this one is positive. So the negative part of this compound, it will be added to the carbon with lesser number of hydrogen atoms. Is this clear? the negative part of this reagent, it will be added to the carbon with lesser number of hydrogen atom. It will be considered as the major product and the other will considered as minor product. So here one hydrogen and here there are two hydrogens, right? So this iodine, it should be added to here and the hydrogen should be added to here. This is considered as the major product. Other one will also produce but in very small yield there. Okay, that's it. I think the Marconi-Cope's rule that we will learn in detail in chapter 13. But you have to remember this point. I will write the statement here. Just 1 minute. Okay, you can just note here the proper statement of the rule I will give you later. Okay, Marconi-Cope's rule. Marconi-Cope's rule. Negative part of the reagent. This is not the actual statement of Marconi-Cope's rule, but this to note the point. Okay, negative part of the reagent, it is added to the carbon atom of alkene with lesser number of hydrogen atom as a major product. That's it. So this is the method of addition of hydrogen halides. When hydrogen halide is added to alkene, alkyl halides is obtained. Okay, it is followed by Marconi-Cope's rule if the alkene is unsymmetrical. Okay, if alkene is unsymmetrical. Is this clear? Have you completed?
No.
Okay.
Added to carbon atom of alkenes. Right?
Carbon atom of alkene. Yes, alkene. Okay. Yes, then one more method in this alkenes, that is addition of halogens. We have learned addition of hydrogen halide, and the next method is addition of halogens. Addition of halogens. Br2, bromine is added, and here CCl4 is used. Okay, CCl4 it is used and the double bond again breaks and the bromine is added to both CH2 groups. This is the chemical reaction. Double bond breaks and this bromine is added to both this carbon atom. And this chemical reaction that is used for detect the presence of double bond in a molecule. Okay, this chemical reaction is used in laboratories to identify the presence of double bond. Identify the presence of double bond. Okay, when we add this bromine in CCl4, okay, bromine in CCl4 to this alkene, bromine in CCl4 to this alkene, a reddish brown color will change to a colorless one. Okay, this one will be, can you tell me in which category this product will be there? Here the halogen group is attached to adjacent carbon atom. So what about its name? Is it geminal or vicinal?
Vicinal.
Yeah, vicinal. So this one is known as vis dibromide. Okay, vis dibromide. If the bromine is added to same carbon atom, it is geminal. So this one is colorless in nature. Okay, then when we add bromine with CCl4, it becomes reddish brown color. Reddish brown color, then it will be converted to a colorless on the formation of this vicinal dibromide. So this reaction, it is used for the detection of the presence of double bond.
Ma'am,
Yeah,
what is reddish brown in color?
when we add CCl4 and bromine to alkene, it becomes reddish brown color. Then after the formation of this vicinal dibromide, it is colorless in nature. Okay?
Yes, ma'am.
Yes. This is clear? So we have discussed different methods from alcohols, then from hydrocarbons, from hydrocarbons itself, from alkenes and from alkenes. Then there is one more method, that is halogen exchange method. And there are two named reactions here. Okay, two named reaction. One is known as Finkelstein reaction and the second one is known as Schwarz reaction. And one more thing, this named reactions, they are much important than other preparation or chemical reactions. Okay, so you should follow and write down the chemical reaction of this named reactions. So this halogen exchange reaction, they are of two types. First one Finkelstein reaction, second one Schwarz reaction, that we can discuss in the next class. Okay, so all of you please go through that different methods of preparation from alcohols. I just mentioned 4 or 5 methods, but more than that in your textbook. Okay, if you can able to learn all methods, please do that. I don't know which method is asking, right, for the question. So the most important one I am mentioned in the class, but you have to follow all these preparation methods. Clear? This is clear, children? Yes. Okay, then we can discuss this Finkelstein and Schwarz reaction in the next class. Okay? Okay. Then thank you all. See you in the next class. Bye.